As part A, we are to express cotangent to theta plus cotangent theta equals 2 as a quadratic equation in tangent theta. Cotangent is the reciprocal of tangent, so that is 1 over tangent to theta plus 1 over tangent theta equals 2. Angle is in terms of theta, so tangent to theta. From the double angle identity, we know that tangent to theta is 2 tangent theta over 1 minus tangent square theta. Okay, you have 1 over a fraction here. So if you are given 1 over A over B, that is just B over A. Then in this case, we can just take reciprocal of the denominator. We have 1 minus tangent square theta over 2 tangent theta plus 1 over tangent theta equals 2. The denominator can be eliminated by multiplying throughout by 2 tangent theta. So we multiply all these terms by 2 tangent theta. We are left with 1 minus tangent square theta. When you multiply this by 2 tangent theta, the tangent theta cancel, and you just have 2. 2 times 2 tangent theta is 4 tangent theta. 3 minus tangent square theta is 4 tangent theta. Rearranging, we just move everything from the left to the right. We have tangent square theta plus 4 tangent theta minus 3. Or we can write tangent square theta plus 4 tangent theta minus 3 equals 0. That would be the quadratic equation. Part B, solve the equation cotangent to theta plus cotangent theta equals 2. For theta in between 0 and pi, we are looking at quadrant 1 and quadrant 2 angles, giving your answer correct to 3 decimal places. Since part A can be written in terms of tangent, we have tangent square theta plus 4 tangent theta minus 3 equals 0. This quadratic unfortunately cannot be factored. If it cannot be factored, we can always use the quadratic formula. Tangent theta is negative 4 plus minus square root of 4 squared minus 4 times 1 times negative 3 for AC. All over 2a. Since a is 1, we just divide by 2. Negative 4 plus minus square root of 16 plus 12 is 28 over 2. Square root of 28 is square root of 4 times 7. So we have square root of 4, square root of 7, which is 2 root 7. Then we have negative 4 plus minus 2 root 7 all over 2. And dividing throughout by 2, we have negative 2 plus minus square root 7. There are 2 values for tangent theta, so let's look at the first value. If tangent theta here is given by negative 2 plus root 7, evaluating using a calculator, we get 0.6458. This is a positive value, meaning that we should get a quadrant 1 angle. Then theta is given by arctangent of 0.6458. And we have a value of 0.573. Theta is in between 0 and pi, meaning that theta is in radian. So make sure that your calculator is in radian mode. That is the first answer. The second term, tangent theta, is -2 minus √7. So that is -4.646. This is a negative value, then we are looking at quadrant 2. Tangent is negative in quadrant 2. We need to find the reference angle. The reference angle is the inverse tangent of the positive value, the positive ratio. We have inverse tangent of 4.646, and that is 1.3588. A quadrant 2 angle is pi minus the reference angle, and that is 1.783 to 3 decimal.